Hi everyone. So today we'll be solving a Leetcode problem number 708. Insert into a sorted circular linked list. So in this problem, we are given a sorted circular linked list, just as it is shown in example 1. And we have to insert a val called insert val here into this sorted circular linked list. But the catch is that the head pointer, it may not point to the least value in the sorted circular linked list, right? So how to solve this problem? So in the case where head points to null, we just have to create this new node with value insert val and then return this new node as head. So in the case where we have only one node in the circular linked list, so in that case our head dot next will be pointing to itself, and in that case whatever is the insert val, we can put it next to this head pointer. So in this case, if we had our value as 1, in that case 3 1 is also sorted, and if the value is greater, for example 5, then that is also sorted. So we'll just have to say that head dot next is equal to new node with that val, and when this new node is created, so we can say that head dot next is equal to head, and then we are done. We just have to return this head pointer. So in case our linked list will have two or more than two nodes, we can have two possible configurations as this first one or the second one. So in the first case, I've shown that the minimum node as starting with the head, and in the second configuration our minimum node is somewhere in between this circular linked list. So in both the cases we can see that the max node is always pointing to the min node. So here the 5 node is pointing to the first node, one node, and in this case also the 5 node is pointing to the one node. So to solve this problem, we have to first identify the min node and the max node, and then we have to start looping around this circular linked list, and we have to check where to insert this val. So to summarize this, we'll have most likely three cases in regards to this insert val. So in the first case, the insert val, it can be less than the minimum node. So, or for example, if you have to insert 0, so we can insert somewhere here the 0. So instead of that, what we can do is that we can insert next to the max node, because this max node is always pointing to the min node. So in that case, the 5 will be pointing to uh, the minimum node or the new node, and then this new node will be pointing to 1 again. So in the case 3b, this insert val will be greater than the max node, and in that case also we can insert or create a new node just in between the max node and the min node. So in the third case, we have to loop around this sorted linked list and check where we have to place our new node. So that's the gist of the problem, and let's see how we'll code it. So first we said that in case if the head is null, we'll just return a new node with the val called insert val, right? So that is our first case or the powder case. And in the next boundary case, when we have a single node, our head will be pointing to itself. So we'll have to check if the head is pointing to itself. And in that case, we just create a new node, head dot next is equal to new node with insert val, right? And what else? So once we have created this new node, then we'll just say that head dot next is equal to head, right? And then we are done, and we'll just return the head. So now if our code reaches this line, so we know that we have two or more than two nodes, right? And first we'll have to figure out the min and max node. So let's initialize these two nodes, min node, max node is equal to min node is equal to the head. Let's initialize to the head nodes, and then let's have two more pointers. One is prev, which will be pointing to head, and the next node is current, which will be pointing to head dot next, right? So what we are trying to do is that we'll start from these two pointers. So let's say that we'll have this as priv and current pointers, and we want to reach to a certain condition so that the priv is actually greater than the current one. So in this case it won't turn out to be true. So in case where you have moved one more place, then also it is not true. But in this case where your prev is 5 and the current is 1, our prev is actually greater than our current. So that's what we are going to do. So we have initialized our prev to head and current as head dot next, and then we'll be looping around, and we'll say that while current is not equals to head, so if prev dot val is greater than current dot val, in that case our min node is going to be the current, and the max node is going to be the prev, and then we are going to break out of it. And if that's not the case, so we'll just have to increment the two pointers, prev is equal to current and the current is equal to current dot next, right? So once we have broken out of this loop, so we can guarantee that the min node and max node have been initialized properly. So now we'll be attacking the first two cases, the 3a and 3b cases, because in both these cases we can just create a new node after the max, right? So we'll say that if insert val is less than or equal to min node dot val, or insert val is greater than or equal to max node dot val. So in that case, max node dot next is equal to new node and then its value, and then max node dot next is equal to min node, right? And then we'll just return the head and we are done. So for the third case, so we can loop starting from the min val, and until we reach till the end of the loop, we have to find the position where we have to place the value. But you can notice that there is one catch, that how will we write our loop? So generally when we write a loop for a singly linked list, we say that while current is not equal to null, right? So in that case, our last, if we write that kind of loop, or we say that while current is not equal to head, or current is not equals to your max node, so in that case the code will not run for the last node. To do things easily, so we have to just break the chain from here. So we'll make this as null. We'll break the chain over here and we'll point this to null. And once we are done looping through this list, then we can create this link, right? So what we are going to do is max node dot next equals to null, and we'll initialize our current to min node, and we'll have to loop through this as if we are looping through a singly linked list. I'll say that while current is not equals to null, so if this insert val is greater than or equals to we'll have to actually take 2 pointers, and because we have to find the position where to insert, right? And it has to be between 2 pointers, 2 nodes, and we have to initialize this priv as the max node. And in that case we can just say that if insert val is greater than or priv dot val, and this insert val is lesser than or equals to current dot val, we'll just make the chain over here. So what we can say that priv dot next is equals to new node insert val, and then this priv dot next is equals to current. And one thing we have to do is that we have to reconnect this broken link. So you have to say that max node dot next equals to min node, right? and then we'll just have to return the head, whatever it is. And if that's not true, we'll have to just increment our pointers. We'll just say that prev is equals to current, and current is equals to current dot next. And then finally we have to return a null pointer. We can return anything, but let's just return head. So I think we are missing out something, but let's see if it runs. Okay, so that got accepted, and if we try to submit, I think we did some mistake. Okay, the first mistake that we did is that I see that when we created this new node, we did not point a reference to itself. So we'll have to do that. That is, we have to call something like this node, or can have just say that head is equal to new node, and this head dot next equal to head, and then return head. Okay, so run it again. Okay, so there are some more errors, and in that case, see. Okay, so the mistake that we have made here is that since so we have initialized the min and max both to 1, and since there is no configuration where the prev is greater than min the current one, so in that case you won't be able to recognize which is the min and max. So for that case, you have to keep on incrementing the min node and the max node each and every other time. So you can say that if this new val this current dot val is less than min node dot val, then my min node is equals to current. And similarly, you have to say that if my current dot val is greater than or equals to my max node dot val, so you have to say that my max node is equals to current. And the reason why we are using this greater than equals to, I'll explain it in a bit. Okay, so we passed the submission. So let me explain why we did this greater than or equals to, but why not in the case of min. So in case you have the duplicate values, so you want to keep on going further ahead. So right in this case, like in this case, my min is 1, and so we both start at 1, and then in that case, even if I see this the same value, so had there been a duplicate values of 1 1 1, so if you want to keep on going so that the max reaches all the way till the end and the min stays where it is. So it will be more clear. Let me give you an example over here. uh, so in this case we had one and another one and another one, and the links are like that. So assuming that, and we have a link right there, and we all start our min and max right over there. So we want our max to reach all the way till the end, and the min node should stay even if there are duplicate cases, right? And this is going to be max node, right? So for that case we write that even if it is the same value, so keep on going, and in that case only you will have this min node and the max node in a configuration where the max node points to the min node, and this is the main trick of the problem. So that's it. Thank you for following through this question, and see you next time.